This is the third video on simultaneous equations. The first video looked at solving a system of equations using the graphical method. The second video looked at an algebraic solution using substitution. And this video is an algebraic method using elimination. So to remind you of the previous videos, this example was used. There's a system of equations x plus y equals 4 and 2x plus y equals 8. Trying to find the x and y values that satisfy both equations. There's only one pair of x and y values that will satisfy this system of equations. We call them simultaneous equations because we use them together. So in the first video we would look at the solution to one equation with two variables. Here x plus y equals 4. Its solution was this line. Every point in this line satisfied that equation x plus y equals 4. Points like 0, 4, 1, 3, 5, negative 1, etc. There was also this line 2x plus y equals 8. All the points on this line satisfied that equation 2x plus y equals 8. So this black line is the solution to that equation. The only point which was a solution to the system of equations had to be on both lines. There's only one point in both lines, and it was the point of intersection here, 4, 0. It was the only point that satisfied both equations. From that we introduced in the second video the substitution method, which was to rearrange these equations to y equals. First equation y equals 4 minus x. Second equation get rearranged to y equals 8 minus 2x. And then a substitution was made. In the second equation, this red y can be replaced by the red 4 minus x, because the first equation tells you what y equals. Y is to be 4 minus x, so that is what y is to be. Y here can turn into 4 minus x. That's a substitution. Solve it for x. Once you get x, go back to the initial equation, y equals 4 minus x. Make x 4 and you work out y. That's solution 4, 0. This was a graphical solution, first video. This is the substitution method. What I'm going to demonstrate is that a third method, the elimination method, is another algebraic method in that you don't use graphs, you're using manipulation of letters and numbers. It can be an awful lot easier. So here is what we're thinking about. If we look at the first equation, there's one x, there's one y on the left, and it's worth 4. The second equation, there's an extra x, 2x, and 1y. So it's only got an extra x, but it's gone from being 4 on the right to being 8. So this extra x must have been worth 4. In other words, the difference between these two equations is the extra x on the left resulted in an extra 4 on the right. The x is worth 4. What's happened is we've found out what x is, and the y's have been eliminated, they've gone. A difference is a subtraction, so you can think about it as a subtraction. This 2x, subtract off that x, and it'll leave a 1x. From this y, subtract off that y, and it'll give you 0. The y's are eliminated. This 8, take off that 4, subtract the 4, and you end up with 4. It's the second equation minus the first equation. So it's a subtraction, a difference. And in one line, we've found out what x is. So that had a lot more working to it. A rearrangement, a substitution, a solving. One line, and we've got what x is. That's why elimination, because there's this elimination of the y's, this is the elimination method. This method can be a lot easier. Now we know what x is, we simply put it into the first equation, but it wouldn't matter which equation, the first equation just looks easiest. Made x 4, and there y is 0. So that's the solution. So because there's been an elimination, this is called the elimination method. And we've eliminated the y's here by a subtraction. This example is Also in the second video on substitution, I'm going to show you again as substitution to show you how much working's involved, and then show you by elimination to show how it's a lot easier. So, substitution method, rearrange the second equation to y equals. There is y equals 8 minus 2x. Take the first equation, and you can replace its y there, which is in red, by the 8 minus 2x, and it becomes 3 bracket 8 minus 2x there. So that's the substitution. Now you break up the brackets, tidy things up, solve it for x. Now you know x, you can put it back into one of the first equations, and this one's the easiest, y equals 8 minus 2x, and work out y. And then you've got the solution. So that's quite a bit of working. Rearrangement, substitution, brackets to be broken, equation to be solved, and then a substitution to find out the other later. Here's the same thing with elimination. Look at the first equation, and then look at the one underneath. It's still got a 2x, it's lost 2y, and as a result of losing that 2y on the left, because that's the only difference between the left hand sides of the two equations, the second equation is 2y less. On the right, you've lost 4. So losing 2y on the left must have been worth losing 4. 2y equals 4. Really what happened is you subtracted 2x minus 2x is 0. X is eliminated. 3y take away y is 2y. 12 take away 8 is 4. So it's simply saying the difference between the two equations is this one, the second equation, has lost 2y on the left, and it's lost 4 on the right. So the 2y is worth 4, y is 2. So look how quick it was to find out one of the letters. This took a rearrangement, a substitution, breaking brackets and tidying up. Took all that just to find out x was 3, and then we could get y. 2 lines, very simple lines. Now we know y, we can put y into this equation. It wouldn't matter which equation, it just looks the easiest with a single y there. So there's a y is 2, 2x is 6, x is 3, that's it, done. Solution. So it was all that working, that's substitution. As well as that, when you rearrange here for y equals or sometimes x equals, you don't want fractions and it becomes really difficult. So sometimes the substitution method just won't work well because it's fractions that become involved. The elimination method doesn't have that problem. Now, there are alternatives, just to point this out. So that's that one done and it's finished. This would be an alternative. It's just to point out you can multiply an equation on the left by some factor. As long as you balance that by multiplying the right by the same number, the same factor, the equation balances. So if I multiply the left here by 3, 3 times 2x and 3 times y, as long as I multiply the right by 3, the equation is still the same equation. It's just a multiple of it. It's still got the same solution. If you drew the solution, it'd still be the same line on the graph. So here we go. The first equation is left as it is. Second equation, everything on the left times 3, everything on the right times 3. And now I've made the same y terms, plus 3y and plus 3y. So when I subtract, when I get the difference, I can go 6x, take away 2x is 4x. 3y, take away 3y is 0, they're eliminated. 24, take away 12 is 12. Basically saying, this left-hand side got an extra 4x. The right-hand side got an extra 12. The 4x must be worth 12. So x is 3, there it is there. And then you put it into one of the first equations. Wouldn't matter which. I could put it into 2x plus y equals 8 because that's an initial equation. 2 3's, add y equals 8. Go on to solve it. Y is 2, same solution. So it's just an alternative. Here it eliminated the x's right away because you get 2x and 2x. Here I multiplied this equation by 3 and made the same y terms, and now they eliminate. You either make the same x terms in each equation or you make the same y terms. It doesn't matter which, you'll get the same answer anyway. Sometimes one is easier than the other. I would say the one on the left is probably easier than the one on the right because you can straight away eliminate the x's. Here's another example coming up after this one. It's just to point out you can multiply up the equations, as we've just done, multiples of the equations, and you can be adding or subtracting the equations together. We've been doing subtraction. We've been saying 6x take away 2x, 3y take away 3y, 24 take away 12. But you can do it also by addition. So you can add equations together, you can subtract equations, you can have multiples of the equations. The aim is to get the same x's, either get the same x terms or the same y terms. So this one, I'm going to get the same y terms. I'm going to double the second equation. Leave the first one alone, that's why it's times 1. So I doubled up the left hand side, 2x plus 2y, doubled the right, negative 2. Now look, they've got the same y terms. Do a subtraction, that is, get the difference. Subtract 5x, take away 2x, 3x. 2y, take away 2y, 0, they're gone. Negative 8, subtract negative 2 is negative 8, add 2, which is negative 6. Divide through by 3, x is negative 2. If you end up with a fraction here, none of the worksheets that I've made available are going to involve fractions. If you click the link in the description, you'll get access to the worksheets with the answers. None of the answers are going to involve fractions. If you get a fraction, you've made a mistake. So, made the y terms to be the same, carried out a subtraction so the y terms are eliminated. Now we know what x is. Pick the easiest looking equation, x plus y equals negative 1. Make x negative 2. Y is 1, that's the solution. X is negative 2 and y is 1. That's it done. This is just to point out an alternative. Could have taken the second equation and times it by 5 and made it 5x plus 5y equals negative 5. Left the first one alone, and they've got the same x's. Subtract them now. 5x minus 5x, 2y minus 5y is negative 3y, negative 8 minus negative 5, that's negative 8 plus 5, it's negative 3. Y is 1. Pick the easiest equation, make y 1, and you get x, you get the same solution. It's just an alternative. Here, I doubled up so I could eliminate the y's by subtraction. Here, I multiplied both sides by 5, so we can eliminate the x's by subtraction. It doesn't matter if you eliminate the y's or you eliminate the x's. It doesn't matter if I use the multiply by 2 or I use the multiply by 5, you'll get the same answer. It's not much more difficult between either of these two. In this case, you can choose to eliminate the x's or the y's. If you're going to multiply up the x's, you're going to start to get bigger numbers. I mean, that's 7x and 4x. You'll get quite big numbers. You won't with the y's. I'm going to eliminate the y's. I'm not going to bother with the x's at all. I'm going to say 2y and 3y. What's the smallest number 2 and 3 go into? 6. I'm going to turn these into 6y. This 2y's to become 6y. I must multiply it by 3. This 3y's to become 6y, I must multiply it by 2. So I multiply the first equation, everything by 3. 3 times 7x, 3 times 2y, and 3 times 1. The second equation, I'm going to double everything up. 2 times 4x, 2 times 3y, 2 times negative 5. So there's what I get. Notice it's plus 6y and plus 6y. Subtract 21x, take away 8x, 13x. 6y, take away 6y, eliminates, gone. 3 minus negative 10 is the same as 3 plus 10, 13. X is 1. Pick any of the first two equations. Doesn't matter which. I've made here 7x plus 2y equal 1, that first equation, and made the x 1. Going to solve it. Take 7 off each side, divide through by 2. That's the solution. X is 1, y is negative 3. So 2y, 3y. What's the smallest number 2 and 3 go into? The least or lowest common multiple is 6. So on the 2 times table, on the 3 times table, they share 6. That's the first number they share on the times tables. And that tells you what to multiply each equation by. So that's the elimination method. And just to point this out, I have been doing it all by subtraction. When I was at school, and some teachers still prefer to do the following. Instead of multiplying by 3 and 2, multiplying by negative 2 here, it simply means you've got a plus 6y and a minus 6y, and then they add. You get the same result, 13x is 13, and the rest of it's all the same. So I tend to do subtract, get the terms plus 6y plus 6y, make them the same, and then subtraction eliminates them. Some teachers might be teaching you to make one negative and one positive, so get positive 6y, negative 6y, and then add them. This is just adding the negative. That's the same as subtraction. Adding a negative is the same as subtract. However, people tend to, to my mind, mix signs up when they're making one plus and one minus. They either forget to do it, or they do it carelessly. Multiplying by negative, you've got to switch signs. It's easy to make a mistake. So I tend to make them the same and subtract. But it's the same as making one positive and one negative and adding. If you click the link in the description, you've got access to a worksheet which will have 24 examples, and it will have the answers with it. So that's the the link in the description. I'll also have the notes there, which were there for the previous videos. Hope you found this video useful. The next video is on problem solving with simultaneous equations. Thank you.